In this lecture, we're going to look at determining the greatest common factor. In this lecture, we'll also look at just the two methods that are used for determining the greatest common factor. We have the listing factors method and the factor trees method. Let's start with the listing factors method. What we're going to do with this in this method is we're going to list all the factors of each number. We're going to identify the common factors, and then we're going to select the greatest factor from the list of common factors. So we're going to look at 12. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 18 are 1, 2, 3, 6, 9, and 18. And so let's look at the common factors. We have 1, 2, 3, and 6. And the greatest common factor of this is going to be 6. Let's try the same method with this. 36. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. The factors of 54 are 1, 2, 3, 6, 9, 18, 27, and 54. And the factors of 72 are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Our common factors here are going to be 1, 2, 3, 6, 9, and 18. And our greatest common factor will be 18, because 18 is the largest of the numbers and the factors. Now we're going to use factor trees, and this method requires us to develop factor trees for each number, express each number in terms of its prime factors, identify the common prime factors, and then multiply the result. So we have 12 also. Let's draw a factor tree. So factor trees is just a method of decomposing a number into the product of its factors. So 12 we have 2, and we have 6 over here, and here we have 2, and then we have 3. So 12 is 2 times 2 times 3. Let's look at 18. We have 2 and 9, and we have 3 and 3. 18 is 2 times 2. So it's 2 times 3 times 3. And the greatest common factor, we're going to look for what numbers appear the same number of times for each number. So we have 2 here and 2 for 12 and 18. And then we have 3 appearing only once for 12. It appears twice for 18. So we're going to only pick one instance. So that's 2 times 3, which is 6. So for 36, we're going to develop factor trees for 36, 54, and 72. So let's start with generating the factor trees for 36. We have 36, we have 2 and 18, we have 2 and 9, and then 3 and 3. So 36 is 2 times 2 times 3 times 3. 54 is 2 and 27. This is going to give us 3 and 9, and then 3 and 3. So this is going to be 2 times 3 times 3 times 3. Now let's look at 72. We have 2 and 36, 2 and 18, 2 and 9, 3 and 3. So this is 2 times 2 times 2 times 3 times 3. So our greatest common factor, so 2 occurs once for all of these numbers, and then 3 appears twice for all of these numbers, which is 18. So our greatest common factor is 18. Finally, we will generate factor trees for 15, 40, 75, and 125. Let's start with 15. For 15, we have 3 and 5. For 40, we have 2 and 20, 2 and 10, 2 and 5. So this is 2 times 2 times 2 times 5. For 75, we have 3 and 25, and 5 and 5. So we have 3 times 5 times 5. And for 125, we have 5 and 25, and then 5 and 5. So this is 5 times 5 times 5. So the greatest common factor is going to be the numbers that appear in for all 4 numbers. So here we have 3 and 5. So we got a 5. There's no 3 anywhere else except 75, so we ignore that. So we see 5 appears here for 15, for 40, for 75, and for 125. So the GCF is going to be equal to 5. The most important thing about showing you these 2 methods is for you to develop one that works for you all the time, and then use that when you're dealing with greatest common factor.